because I'm having problems. I've recorded other office hours, and then for some reason YouTube doesn't want to let me upload it. So hopefully we won't have that problem this time, because I want to make sure that people who can't make it can actually hear the recording. So if you all could just let me know who your intro stats teacher was. I've got a couple of names. I'm just curious. Okay. And who said Dill? Somebody said Dill. I don't remember who it was. Jennifer, thank you. Okay. So I'm sorry, you have to type everything out. That's really, I mean, at least you can hear me. That's good. Okay, so let's see. Marilyn and Denise. Who was your first your intro stats teacher? And there's somebody else on the call that I've missed. All right, I hope you can hear me, because I'm not getting. See, Marilyn and Denise. I would love to know who your intro stats teacher was. So if you can just let me know, I'd appreciate that. Okay, so here's what I wanted to do today. I've been grading a lot of assignments. I've been grading some redos as well. I'm finding that those of you who've attended office hours, my office hours in the past, are actually doing fairly well. And those people who haven't attended office hours in the past are having a tougher time. Now, that may be a coincidence. It's entirely possible, but perhaps not. Also, Robin has office hours. She was very happy that several of you came to office hours this past Sunday, because I think she said that was the first time she had people from this section. She's had people from Ray's sections attending. So please try to, if you can't come to my office hours, and I understand that some of you are working at the time that we have this thing, I'm doing my very best to upload last week's recording. I tried, I don't know, half a dozen times, and I could not get it to upload to YouTube. So I don't know what the problem was, but I'm recording these. I will try to make sure that I figure out what the problem is if this one doesn't go get uploaded. But usually this is the time that not only do I answer questions, but I try to give you little tips on how to do the assignments. So in grading your assignments, I am noticing some very kind of common kinds of problems, and some of them are pretty basic, and not having that down, I think, is really handicapping some of you. So what I thought I would do today, I do want to spend some time answering questions about the upcoming assignment, and I'd be happy to answer questions about the assignments that have that come through in the past. But I'd like to start with just kind of some basic stuff, unless somebody has something pressing that we need to address first. So let me first open it up and find out whether my agenda as planned sounds like a good plan, and whether there's anything else beyond the upcoming assignment, the last assignment, and just some basic stuff that you all need. Anybody? Well, since not too many of you are speaking, then I guess I'll just go ahead and do what I had intended to do, and then I'll hopefully by then you will have some questions that you want to ask. Let me start out with one of the difficulties that many of you are having, and that is in figuring out what's an independent and what's a dependent variable. And that's a pretty basic thing to know when you're going to do analyses, because if you decide that the wrong variable is the dependent or the independent variable, and you plan your analyses accordingly, you're going to have the wrong results. And so I think it's really, really important to figure that out. I would like to suggest that you use the decision tree that is in the M&B book on page 22 in reverse. So for example, if the assignment is analysis of variance, which it was last time and which it will be for tomorrow's assignment, that you go right to the section under tests where it says one-way ANOVA. And if you use the decision tree backward, you will see that with a one-way ANOVA there are no covariates. Okay, fine. But there is a categorical independent variable and a quantitative dependent variable. So then when you think about the variables that you have, like on the last assignment, the second part of the last assignment, the variables that we had were sex as in gender and minority versus non-minority status, as in white and all others or something like that. And I'm now forgetting what the dependent variable was. Somebody help me out if you happen to have access to that in your brain. Current salary, that was the dependent variable. Now, if you look at the decision tree, it makes perfect sense that sex would be a categorical variable, male or female, and that minority status, white, non-white, would be an independent variable. That's a categorical variable, as the decision tree shows you. And it makes perfect sense that salary level would be the dependent variable because it's quantitative. It's on a continuum. Okay, so I think it's important, if you're confused about what's what, use the decision tree backwards to figure out what variable is what variable. It's really important that you do that because usually in every assignment we ask you to formulate a hypothesis, and that's the second thing that I wanted to talk about. It's that when you formulate a hypothesis, statistically, we are indeed testing the null hypothesis, which is a hypothesis of either no difference or of no relationship. And in general, when we think about stats, there are kind of two categories, or really three or four, but in the decision tree, it really focuses on these different categories between the kinds of questions that we're asking. We're either asking a question about relationships. How does this variable relate to that variable? How does this variable correlate to that variable? And in the decision tree, it's the whole first series of stats, which is degree of relationship. Or we're asking about group membership. How does this group differ from that group? You know, how do males differ from females? How do whites differ from non-whites, etc.? So the whole next set of stats that we have been talking about actually are those that have to do with group differences, and then the third and fourth have to do more with the structure of the data that we're looking at. I don't want to talk about them right now. But in terms of hypotheses, when we're talking about a hypothesis about relationship, the degree of relationship, we're going to talk about the correlation between this and this, or whether this variable predicts that variable. But when we're talking about group differences, we're going to talk about whether there's a significant difference between this group and that group. We're going to talk about whether the males will have a higher salary than the females, or the whites will have a higher salary than the non-whites. And the null hypothesis, of course, is there is no difference, and that's what we test statistically. But we always ask you to make a prediction, to formulate what's called either an alternative hypothesis or a directional hypothesis, which is, I believe, I bet, I predict that males will have a significantly higher salary than females, or that whites will have a significantly higher salary than non-whites. Notice that the categorical variable, your dependent variable, is the organizing principle, and that the dependent variable is your outcome. You're saying that, you know, I think that gender makes a difference in terms of what kind of salary you get. I think that ethnicity makes a difference in terms of what kind of salary you get. So I think it's really important that you're able to formulate very specific directional hypotheses, because otherwise a lot of what we're doing statistically I think is not going to make sense to you. In general, if you have a phenomenon where you really don't think there's going to be any difference, for example, if you think that I'm trying to think back to the first part of last time's assignment. If you think that the degree of happiness that somebody experienced isn't really going to make a difference in terms of how many hours they're going to work, when you do a study, if you don't think there's a difference between your groups, the happy groups and the not happy groups, then usually you don't want to formulate a hypothesis at all. And that's a little complicated to explain, but basically, if you think there's no difference and you get no difference, we really don't know whether there is a difference that you failed to observe or failed to find, or whether there is no underlying difference at all. And for that reason, we generally want to formulate directional hypotheses, and we only want to formulate those hypotheses where we really think there's going to be a difference. So it's okay to say, I don't think there's going to be a difference between these two groups, and so therefore I'm not going to make any hypotheses at all. That is perfectly okay to do. So please stop me, guys, when I'm talking about this stuff if there's anything that doesn't make sense, because it's a little hard. I'm not getting a lot of feedback from you all. I can't see your faces, and when I teach, I look. Yeah, go ahead.
So you said there's a directional hypothesis or a what?
It's sometimes you'll hear it referred to as an alternative hypothesis.
Okay.
But it's really your prediction. And, the metaphor that I use is when you go to Las Vegas and you decide to bet, you're at the roulette table, you're going to bet on red or you're going to bet on white. You're not sitting there and going, well, I don't know how it's going to come out. Now, of course you don't know how it's going to come out, but you're making a bet. You're making a prediction. And in the same way with research, you really don't know how it's going to come out. That's why you're doing the research. But you have a bet. You have a hunch. And your hunch comes either from reading the literature, which has told you that, this phenomenon seems to be operating, or from your clinical experience, because you've been working with patients and, this phenomenon seems to be happening. So that's what we want you to do. We want you to formulate a directional, sometimes called an alternate hypothesis. And we don't want you to say, there's no difference, unless you believe there's no difference, in which case you say, I can't make a hypothesis because I don't think there's a difference. Yeah, go ahead.
Okay. And you said the dependent variable is always the outcome, and the independent variable is, I missed what you said.
Well, it's the effect or the cause.
The effect or the cause. Okay,
yeah.
Thank you.
So now if you were doing an experiment, the independent variable would be that one group gets shock therapy and the other group gets to watch cartoons. That's your independent variable, the kind of treatment they're getting. And in the case of some of the things we've been looking at, they're dichotomous variables like gender, like whether a person is white or non-white, or any other things like that, where you can put people into groups. It doesn't have to be 2 groups. It could be 3 groups. You could have whites, you could have African Americans, and you could have all others. You could have 3 groups, and you could do the same salary study that was suggested for the last assignment, and you could have 3 groups, not 2. Okay. So yeah, please, jump in there, because I really can't see your faces. If I were teaching you de vivo, I'd be looking at your faces, and as soon as you got confused, I'd see it and I could attend to it. And I can't do it here, so I need your help with that. So that's the very first thing that we want you to do in general. So the upcoming assignment has a research question, and from that research question, the very first thing I would like you to do is to actually formulate a hypothesis. How do you think it's going to come out? And we'll come back to that, but I just wanted to say that that's the first thing you want to do. I can't read my own handwriting here. I made a little list of things I wanted to do. Okay. Then the other thing that I want to talk about that was used a lot in the last assignment, actually the last couple of assignments, was the assignments talked a lot about main effects and interactions. And a main effect is simply the effect of a single independent variable at a time on the dependent variable. So in the last assignment, a main effect would be sex, whether you're male or female. And it's a main effect because it has an effect on salary all by itself, or there's a prediction we can make that we think that males on average will make significantly more money on average than will females. Or we have a hypothesis we're going to make that whites, on average, will make significantly more salary than non-whites. That's a main effect. But It's a separate main effect. First main effect was that due to sex by itself, and the second main effect was due to ethnicity by itself. Now, an interaction has to do with the combined effect. Maybe it's not that simple. Maybe it's not that males make more money than females. Maybe it's white males that make more money than all kinds of females or than other kinds of males. So there's other ethnic kinds of males. So maybe there's an interaction, there's a combined effect. If you want to understand who makes the most money, just looking at gender isn't enough. We also have to look at ethnicity. So we think it's something about that combination of sex and ethnicity that accounts for who makes more money than who. So I think it's important to understand the difference between a main effect and an interaction. And again, some of you were pretty confused about that. So when they asked you what the main effect hypothesis was, they wanted to know, what's your prediction about which sex group is going to make significantly more money than which other sex group? That's one main effect. And the other main effect is which ethnic group was going to make more money than which other ethnic group, another main effect. And then when they said, what's the interaction? Well, how do sex and ethnicity in combination allow us to understand which group is going to make the most money? And I hope you understand that when you're looking at males and females and whites and non-whites, when you look at the interaction, there are four groups. There's white men, white women, non-white men, and non-white women. That's effectively four different groups. So the interaction is going to look at those four groups and the combined effect of sex on the one hand and ethnicity on the other as they go together. So that's really important. All right, I'm just like checking things off my list of things that I wanted to make sure you guys were on board with. Sorry, I'm trying to read my handwriting. The other thing that I guess people get pretty confused about is what a P-level is. P-level or significance level. And you should probably know that when we do research, we are never 100% sure that the relationships that we are predicting are happening are actually happening 100% of the time. So the statisticians have, as a convention, agreed that if 95% of the time we can have 95% of confidence in our results, but we can't ever have 100%. So that means the probability that we might be erroneously concluding something can be as little as 5%, p less than 0.05, and we will still find that our results are going to support our predictions. However, if it's 6%, p less than 0.06, or 10%, p less than 0.10, or 31%, p less than 0.31, then we, there's a sufficient amount of doubt about our findings that we cannot, with any degree of confidence, conclude that our hypotheses, as we have formulated them, are supported by our data. So that's why when we look at the results of our statistical analysis, whether it's an ANOVA or a t-test or even a bivariate correlation, we not only want to look at the number, in terms of analysis of variance, that would be an F value. We want to look not only at the F value, but we also want to see if it's significant, meaning if the P is less than 0.05, then when we conclude that indeed there's a difference between males and females, then we are going to be correct 95% of the time, and only 5% of the time, P less than 0.05, are we possibly going to conclude that in error. So that's what a P-level means. It has to do with really how confident we are about the relationships that we're talking about in our hypotheses and that we're testing through our statistical analyses. Again, I think that's important because people get really confused, and then when you add things like effect sizes and all these other numbers, people get very confused about what a p-level is. But a p-level is very important, and in general, when you're looking at your results, you're wanting to see a p-level at less than 0.05. And in fact, what I think I'd like to do, if I can find it real quickly, is hold on, get rid of this. Hopefully you're all seeing my screen, except for those of you who unfortunately are on your phone line.
Thank you for saying this. You're the first person who actually made it make sense to me by saying that the 0.05 is the equivalent of saying, 95% of the time.
Okay, good. I'm glad. I mean, it was obvious to me that some of you didn't know that, and without knowing that, I can see why it would be so hard to do what you're doing in this course. And I kept running into this over and over again. I thought, my goodness, I really need to explain that to you all. Okay, so if you look at this, this is output. This is actually incorrect output. I just ran this so we could have some data. This is output from the salary A data file. And you might remember that on the last assignment, there were two salary files. There was a salary A and there was a salary B. And the salary A data file was the one you were supposed to explore to look at how the scores were distributed or how the data were distributed. And in fact, if you did the assignment correctly, what you found was you had pretty skewed data. There were a lot of, sorry about that, there were a lot of outliers. And so therefore, in order to do an analysis that made any kind of sense, you had to transform the data. Now, because the authors of the M&V book and your instructors did not want to have you spend a whole lot of time figuring out how to do a transformation, they said, let's go ahead and transform the data for you guys. And that's why they created the salary B data file, which was the same data, except the salary data, which were the skewed data, were transformed, and you could then do your analysis. So here, what I did here is I ran the ANOVA on the salary A, which you shouldn't have done. So some of you did that. That was wrong. But I ran it just so we would have some data to look at. So if you're seeing my little cursor going around in circles here, when I get an ANOVA table, the very first thing I do is I go to the end of the table, and specifically I look for the significance column. And anything that's under 0.05, that means it's significant. It doesn't mean it's not significant. Some of you actually said that means it's not significant. No, if it's less than 0.05 and 0.000 means that it's actually less than 0.001. It's very, very significant. So all of these, I'm sorry, I don't know why this keep popping up. Anyway, all of these F values here are in fact significant because they're all greater than 0.05. Every single one. Doesn't like my doing what I'm doing with my cursor, I guess. So every single one of these is significant. Now the next thing I do is I go back and look at what is the source, meaning what accounts for this particular F value. So don't worry about corrected model and intercept, and that's part of what goes into the calculation, but for the purposes of interpretation, you don't need to worry about it. But you can see here sex, minority, and sex times minority. So here we have the main effect due to sex. Is there a significant difference between the men and the women on the dependent variable, which is current salary? And when you look over here, you find that yes, indeed, there is a significant difference. That significant difference is based on the F calculation. The F calculation, I don't know how much of this to go into because I'm afraid of losing you, but maybe this will help. This sums of squares, which has, it's collapsed to the decimal, has moved over. It's, 2 and some million numbers are quite large, so they concatenate them this way. But that really is a measure of how much the scores by sex differ from each other. And so the sums of squares is the amount of difference between the scores. And that number is usually divided by the degrees of freedom, which is this number, and then you get the mean square. I'm going to explain this to you. You don't have to know this, but that might help some of you understand this. And then there's an error term, and there's a sums of squares for that, and a degrees of freedom. And it gives you, when you divide this 470 into then that number, you're going to get this number, the mean square. If you divide the 1 into the 2.25 blah blah blah, you're going to get that number, which is the same, of course. And when you divide this 1 into this number, you're going to get this number right here. And then the way they get the F value is they take this 2.259 blah 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 and divide it by this number, and they get 64.81. So I don't want you to think these numbers are magic. That's why I'm even going through this exercise. Ditto for minority. This number 7.834, etc., divided by this number is going to give you 22.480. And again, just so you know, this is really 7,834,000, a bunch of numbers, and it's been concatenated. So that's why you still get, 22.480 for that F value. But this number here is basically a ratio that allows you to look at the relationship between how much variability there is in a set of score and the number of groups there are. This degrees of freedom is the number of groups minus 1. You have 2 sex groups, minus 1 is 1. 2 minority groups, minus 1 is 1, and so forth. And then there's a table that allows you to look up for 1 degree of freedom and 470 what the table F value has to be. And when you look that up, you're going to find that indeed that number is whoppingly big significant. Back in the days, pre-computer, when people had to do these by hand, that's how we did it. I actually did this in graduate school myself. We did it by hand. We looked in the table, and it told you what the significance level. The disadvantage of doing that is it took a whole lot of time. The advantage is perhaps we understood better that these numbers weren't magic. I mean, I think one of the downside of having the computer do this for you is you don't understand. You just got these magic numbers, and if nobody's ever explained to you how those numbers came up, you don't know what it means. So I really want you to at least get some sense that this isn't magic. This is has a way in which there's a formula behind it that accounts for this. But anyway, back to the significance level. This is where you can conclude that indeed there is a difference. There's a significant difference due to sex. There's a significant difference due to minority status. And there is a significant interaction between sex and minority. That then allows you to take your results back to your hypotheses. The reason you start with a hypothesis, it's your prediction. Then you get the data, and based on the data, you conclude whether or not your hypothesis is supported. So if you had, using this bad data file, but if you had predicted that sex would indeed be a significant variable, meaning that one group, and hopefully you predicted one group over the other, that the men are going to get a higher average salary, significantly higher salary than the women, that this would show you that indeed, yes, according to these data at least, the men in this sample do get significantly more money than do the women. And then you would do the same thing with a minority finding. You would say, oh yeah, that too is significant. So that means that maybe that the whites or the non-whites got significantly more than the other group. And I'm saying that because the next piece of information you have, and I don't think I printed it out here, I should have, but is the means. Because without the means, all that this tells us, all that this tells us is that one of the sex groups is different from the other, or one of the minority groups is different from the other. When you look at the means, like if the mean for the men is a bigger number than the mean for the women, and the significance level is less than 0.05, then indeed we conclude the men make significantly more money than the women. Our hypothesis is supported by these data. Okay, so I wanted to show you how this all fits together, because otherwise this is like some kind of magic out there where you push some numbers, and if you don't understand the underlying thing of what you're doing, this may never make sense to you. I really want it to make sense to you. So, questions about what I've said so far? I have now lost my cheat sheet. Hold on one sec while I find it to make sure that I cover all the things I wanted to talk about.
So, and in the analysis of variance, when we're reporting the significance, we have to make sure we report the F value, not say p-value. Is that correct?
You want to report all of the above. What you want to
All
report
of
is you want to report the F value, and in parentheses you want to put the degrees of freedom. So what would the degrees of, if you were reporting the F value for sex, what were the degrees of freedom that you would put in parentheses right after the F value?
Okay.
What would they be?
Oh, 1. And, well, you'd say an F value of 64.81, and then in parentheses put the number 1.
No, you'd have to put also the degrees of freedom for the error term. So you'd put 1 comma 470 equals 64.81, and then you'd put p less than 0.05 or 0.01, or in this case 0.0001. The thing I didn't ask for this to print out is the effect size, because the next thing you want to put in there is the effect size as well. Because the effect size tells you if it's significant, how strong a relationship is this after all? Because the fact that it's significant is good, but it doesn't tell us whether it's a strong relationship or not. Now, I think I've I don't know how I did this. Oh, here we go. I thought okay, I found my cheat sheet. Okay, so does that help answer that question? I can't.
Yes, it does. Thank you.
Okay, great. And so, and then that was a very good question, because it actually takes me to my next point. When you're asked to write up a results section, here are the things you want to say. You want to repeat what you did. So we did an analysis of variance, looking at the independent variables of sex and minority status and their interaction. We had hypothesized that men would make significantly higher salaries than women. We had also hypothesized that whites would make higher salaries than non-whites. And we finally had also hypothesized that white men would make significantly more money than any other combined group of sex and ethnicity. So they make more money than white women, than minority women, than minority men. So you repeat that. This is what I hypothesized. And then, again, based on these data, if they were correct, the findings were that there was indeed a significant sex main effect. And again, I don't have the means here, but the means show that the men scored higher. And that the F parenthesis 1 comma 470 is equal to 64.81. P is less than 0.0001. And the eta square is, and again, I didn't print this out, I should have. And then you go on, and minority status is also significant, showing that whites make significantly more money than non-whites, that the F is equal, the F1 comma 470 is equal to 22.48, the P is less than 0.0001, and the eta squared is whatever it is. And you go through each one at a time. Okay? That's how you write the results section. So everything is there, and you know exactly what you have to say. Let me think what else I wanted to say to you. I hope you all saw the email I sent regarding the assignment due tomorrow. Just, it's kind of repeating a lot of what I'm telling you. Make sure that you do write some hypotheses. Make sure that you make some hypotheses that show the direction of the effect. And so therefore, when you write your results section, that you can comment not just that you got a significant F value, but which group got a higher score than which other group. In that email, I also told you that it wasn't really necessary for you to do some of the QQ plotting or the stem leaf plotting. You can do some of the other kinds of plots that we've done in previous assignments to make conclusions about the distribution of scores. So I hope you got that email. I'm going to probably repeat some of that again when we go over any questions you have about the upcoming assignment. But I wanted to make sure that if you haven't seen the assignment, please make sure you look for it. I did send an email to everybody because I just wanted it to be clear. And I don't want people to feel like they're not getting adequate enough explanations of what I'm looking for. The other thing I wanted to say is you may have noticed that the assignments build on each other. You know, you started out, assignment number 1 was learning how to read the decision tree and being able to figure out, based on the kind of data you have, what kind of stats you need to do. The second assignment was looking at just some basic things on how you take a data file and begin to explore the data. The third assignment actually involved looking at analysis of variance for the first time and making some predictions, and then going through a process in which you explore those data and talk about what each piece of output means. By the way, I just want to say that some of you really had difficulty with the fact that I don't just want you to give me output, just copy it in your assignment. I want you to tell me why you put it there and what you're looking at and what you're concluding from it. I mean, there's a reason you do this. In most cases with some of that explore data, you're looking to see what kind of distribution you have. Is it skewed? Is it, what's the kurtosis on it? Are there outliers? Do you need to do transformations? Do you need to recode anything? I mean, all of that is what we're asking you to look at before you begin to do your analysis. If you're doing a dissertation, you're going to have to do that. That's part of the process of getting to doing the analysis. The reason the data that's on my screen isn't correct is because this is the salary A data, and if you did that part of the assignment correctly, and you took various pieces of the output and you showed me step by step that based on this plot, this plot, this plot, this plot, that there were a sufficient number of outliers, or the data was sufficiently skewed that running that analysis without those data would give us incorrect results, and therefore you needed to transform the data, you did it right. And then you did the analysis with salary B, which gave you somewhat different findings, including the fact that the interaction turned out not to be significant using the salary B data file. But all of the output that you gave me before was explained, so I understood the process that you went through. I could see, those of you who did that well, I could see that you got it. You knew exactly why were you looking at a histogram? What is it telling me? What's the stem and leaf plot telling me? What's this telling me? And therefore, when you reach your conclusion, so therefore, I'm going to use salary B to do the analysis because that current salary variable was pretty skewed. And so I'm going to, ordinarily you do your transformation yourself, but here they did it for you. I'm going to look at salary B and do the analysis on that. That's really why I want you to give me as much information as you can. I mentioned before that doing research really requires you to be anal. You have to be very precise or you're going to end up with the wrong stuff. It's a very deliberative process. It takes time, and that's really why we say to you, give yourself time to do these assignments. Don't wait till the night before it's due, because you're not going to have time to go through the rigorous step by step by step by step that you need to do this correctly. So give yourself the time.
Dr. Harwick, jump in here?
Yeah, please.
So it's very hard, even having started the assignment way early.
Yes.
It's very hard to judge the amount of time. And for example, for whatever reason, it took me 13 hours to get through just the first part of this assignment, just putting all the data in. Like, I put the stem and leaf plots in and that stuff. But so when it snowballs to 13, 20, 30 hours on the assignment, it's almost impossible not to be, in a week or a 2 week period, not to be really ended assignments and stuff.
I'm trying to figure out why it's taken 13 hours to do that first part.
Because having to import every, because of the levels in the scales, so you're doing like 16 or 8 and 8, you're having to bring each of those things into Word tables and
so it's a mechanical part of importing output from SPSS.
Actually, a
Word?
formatting. It takes hours to bring that to a Word document, and I'm efficient at it.
You know what if I were you, I think if I really had that problem, I think what I would do is I'd print out the output in SPSS and I'd cut and paste it and I'd scan my file back in there. That's what I'd do. I agree with you. I wouldn't have the patience to have the format be all, all perfect, importing it from SPSS into Word and having to move things around. And if it's taking you 13 hours to do that, I would think cut and paste. Now again, I'm old and I'm old-fashioned, and maybe that's why that seems like an okay solution to me. But I would think that would make you get it done faster. Just the mechanical part.
Yep. Okay. So it would be actually useful to have some time estimate on assignments to compare where we are. If you think an assignment like this should take us maybe 10 hours, it would be useful to have that so that I know if I'm way off. If it's supposed to take me 30 hours to do a thorough job, then that'd be good. But to just say start ahead of time because it's going to take a lot of time doesn't allow me to gauge, and I get completely it throws off all my other assignments.
Okay, then here's what I need from you guys, because I can't do this. For me, this is easy, right? Remember, I'm teaching this, so it's easy for me. I'm understanding what you mean about just the formatting taking a long time. What would be very helpful to me, it's going to require you to do something for me, but sit down, and if you could put down for me how long it's taken for you to do each of the assignments and break it out and say, the conceptual part took me 3 hours, and just the formatting part took me 12 hours, and the whatever part took me whatever. I don't have a clue how to estimate that. So you can do that for me.
So that would be great if we could do that. I guess I would like to know just sort of I don't know, even a guesstimate of how long you reasonably think these things should take. So people are saying notes. I see notes coming up now, 25 to 30 hours.
Yeah, I see that for many of you, this is obviously an issue, and my goal isn't to beat you to death with work, really, so I'd like to.
We're screwing up, If it's a gauge for me to know if I'm screwing up.
Okay, all right. Well, if you all could provide me with that information, send me an email saying, okay, and maybe we could. I mean, the problem is I won't be able to tell you for the upcoming assignments because they haven't been done yet. I will also talk with Robin because she's been a student in this course before, and she should be able to give me some kind of an estimate that would be way better than my estimate of it. And I understand how frustrating it must be not to know how much time do I set aside from this. But also keep in mind that this is sort of like learning a new language. And when you learn a new language, it's hard. It's hard because you don't understand a lot of things, and it takes you more time. And as you get more fast with this, and that's why I think the fact that the assignments build on each other, and that's the good news is that once you understand it, and some of you have gone from having a terrible time and doing pretty bad work to really doing well. I've seen the transformations in some of you in a really short period of time. I think once you get it, you're going to get it. And it won't take you so much. Now, the formatting, I can't speak to. That's why I said, personally, I'd be cutting and pasting just because I just wouldn't have the patience.
I get you, and I was. It wasn't just the formatting. I mean, we have to do all the histograms and stuff like that.
You do. But, that doesn't take, the running of those things doesn't take very long at all. That takes
it doesn't
seconds.
Take long, and I discussed, the cutting, pasting, and the discussion of the data took, the 13 hours for just the first part.
That's that's a long time. I understand, and I understand that that's really frustrating.
Okay.
But help me with that, and then I will see what I can do, and I'll also talk to Robin about how long, just estimates of how long things should take.
Yeah. Like the fastest person versus the slowest person.
Well, that's the problem. There's a huge amount of diversity. I have some people that are turning in the assignments early each time. I won't name anybody, and I have other people that are not. So it's really hard to estimate, and I think that probably a better gauge than how long it should take other people to do it is how long it has taken you to do these things in the past. And if you know that it's taken you a lot of time, then I'm afraid I'm going to have to say that in order to do well in the course, you're probably going to have to devote the time to other assignments.
Yeah.
Then that's not a great answer, I'm sure, but it's my answer right now. But let me see what else I can find out about, kind of a range of how long things should take.
Okay.
Okay. Do you all want me to talk about the assignment that's due tomorrow? It's really very much like the assignment that was due last time, the one that you just got back, assignment number 3. It's a little bit less detailed because we're telling you don't bother to do some of the plots. But I see a yes please from Denise, so let me go through it. So basically, there's a database. Hold on one second. I actually have it on my computer someplace, which has been provided to you. It's on Moodle, and it's a reduced set of data, meaning there's a very large database, and this is a small subset that has been pulled out that has basically 5 variables plus an ID number. So it has, it has attitudes about the mother, and it has race, and it has family status, and it has feelings about the father, and it has attitudes about the father. So basically what you're asked to do, first off, that first variable is attitudes about the mother's support for the relationship between the respondent and his or her father. And that's going to be the assignment number 6 that's going to be due in a couple weeks. So don't worry about that variable. It's not going to be relevant for tomorrow's assignment. It will be relevant for a couple assignments down the road. But basically, you're asked to start out with a research question. So are the feelings about the father and attitudes about the father different among different race and ethnic groups? And are these differences related to the family structure in which the persons grew up in? So the very first thing you have to figure out is what are your dependent and what are your independent variables? So can anybody tell me what the dependent variables are here?
Feelings and attitudes?
I'm sorry?
Feelings and attitudes?
Right. Yeah, I'm sorry. I was having trouble. So the feelings about the father and the attitudes about the father. Those are the 2 dependent variables. Now, that already tells us this is an exercise about analysis of variance. Analysis of variance allows us to do a single dependent variable at a time. We have 2 dependent variables. So that automatically tells us we got to do 2 analyses. Right?
Mm-hmm.
Okay. So now what are the independent variables?
Family structure and race?
Absolutely. So what would the main effects be?
Can I stab this one because I might get it wrong?
Great, go for it.
So, a main effect, you want a main effect for each independent variable. So you would say that the attitudes and the feelings for the father, race has an effect on the attitudes and feelings for the father.
Okay, almost.
Yep.
Almost, because
Okay.
you want to keep each dependent variable separate. So you want to say race as relates to attitudes, and race separately, relates to feelings.
Okay.
But
and
then
family
the next thing,
structure.
right. But before you do that, though, if you were going to formulate a hypothesis, you need to make a prediction.
Right. So race would have a positive impact on feelings.
No, because you're talking correlation when you do that. So we need to go back and we need to see how race is labeled. And here we've got 5 racial groups. We've got African American, Asian American, Hispanic, non-Hispanic, white, and other. So we need to make predictions about these racial groups. Maybe we're going to say that African Americans will have significantly more favorable, go back to the data, more favorable feelings about the father than
Okay.
will other groups. Maybe that's our hypothesis. I don't know.
Do you need to do that for each level of race then? Do you have to
Well,
make a
you
separate?
could. I mean, if you think that the people that will have them in it, maybe you're going to say, well, I think the African Americans will have the most favorable feelings about the father. They'll be followed by Asian Americans. And I don't know about the others, but maybe I'm going to say whites are, non-Hispanic whites will have the least favorable. So, you don't have to do it about each one, but, again, if you were doing this as your dissertation, you would know the literature. The literature would say something about certain groups, and you wouldn't know about the other groups. So you only make those predictions that you have some reason for believing or so based on the literature or your clinical experience. Now, in this case, you don't have either of those. We're not going to ask you to go read about this. So come up with a hypothesis of something that might make some sense. Okay, so that's a main effect for race on the feelings about the father, dependent variable. Now, continue with the feelings about the father and give me another main effect.
Someone else? Or do you want me to continue?
Up to you guys. I think you better continue because nobody else is speaking.
Okay. So a main effect for family structure, or no, for feelings about the father. Okay, so
Well, stick with, I like what you're doing. I think you should take each dependent variable one at a time. So the first one is about feelings, and you talked about race. Now, what about the other main effect having to do with feelings about the father from these data? If we're going to go with family structure, I suggest that is a good strategy.
Okay, so
But you got to first look and see how
what my
the variable has been coded.
structure.
We don't want.
So there's like living with biological mother, living with both biological and stepfather. So I would make a prediction that would say living with both biological mother and father favorably increases feelings for the
Think about
father.
comparing groups, because then the wording is easy. If you say this group will score significantly higher than this group.
So people living at home with both their biological mother and father compared to people who are not living with other living arrangements, which I would not say it that way, show favorable.
Will score significantly higher on the feeling variable than the other group.
Oh my God.
Make that comparison.
Okay.
That's the thing. And then you do the same kind of thing with the attitudes, obviously. Right.
Okay.
And now what about an interaction hypothesis?
So then I would take I would say that kids who live at home with both their biological mother and their father and are Hispanic show significantly more favorable feelings towards their father than other people.
You got it. Perfect.
Okay.
Okay. All right. So anyway, so there's your hypothesis. That's the first thing you need to do. The second thing you need to do is you're going to go through and you're going to explore the scales. So the same kind of stuff you've been doing about using Explore to determine the distribution of scores, except you don't have to do every single one of those plots. So leave out the QQ, leave out the stem leaf. That means you probably want to do some kind of a line graph. You want to probably do a histogram. You probably want to look at the summary statistics and all of that. And in fact, I think in the assignment it details some of the things that you want to do. So what are the characteristics of each of the variables? And then tell us, and then pull out the output that shows that. Have the data been cleaned appropriately and are missing values defined? Go through and show us that by looking at the data. Are the scales normally distributed? If they're not, do you think they should be transformed, or do you think we should delete outliers? Don't do it. Just tell us, show us the output that says to you, these data are very skewed and we really should transform the data, or we should delete outliers because they're so far from all the other data that they will probably distort our findings in some fashion. So first part is explore the data. You tell us what you would do with it. Don't do it. Just tell us what you would do with it. And then you run your analysis. Now what the instructions tell you to do is to first do just with race, then with family structure, and do it separately for each of the variables. Looking here, it looks like sorry, this is an assignment, another assignment that Ray made up. So, so basically, first he wants you to do it as two one-way ANOVAs, and then to run it again with both of the independent variables in there. And then make sure that you do post hoc analyses, because unlike the sex and minority status assignment from last time, there's more than two groups. And if it turns out that the overall main effects are significant, you won't know which groups are different from each other. So you have to do the post hocs to tell you that. Make sure you do those. And then make sure you have, the ANOVA tables, and that you interpret your findings and write a summary. What do your results tell you? So write it first for the feelings variable, and then write it secondly for the attitudes variable. Talk about within the feelings category, talk about the univariate ANOVAs, where you're looking first at race by itself, and next at family structure by itself, and then when you do the factorial ANOVA, which you put both of those variables, where you have two main effects and an interaction effect. And then do the same thing again separately for the attitudes about the father. And so when you write up that last summary section in which you talk about, you summarize what you did, you list the hypothesis you had, you tell us what the F values were, as we've already talked about, you talk about the effect sizes, and you conclude that your hypothesis was or was not supported by those data. Questions? I want to honor your time. I mean, I'm happy to stay on the line if it'll help some of you, but I did set up the call for an hour, so anybody that needs to go, I want you to feel free to go, basically. But questions, I don't want to leave you with questions.
I have no questions.
I don't have any either.
Okay.
This was very helpful. Thank you.
Okay, and remember, when I send you one of those nasty little messages, they're probably experienced that way by you. I don't mean them that way. That says, "Hey, you get to redo this." I'm sure that doesn't feel very good to get them, but on the other hand, it is an opportunity to really understand this thing better. So then, when you do the next assignment, it's certainly when you get to do the part 2 of this assignment, which will be 2 assignments down the road, it's going to be so much easier because you will have understood so much more about this. And feel free, please, 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 attend Robin's office hours and come to my office hours whenever you can. And if you can't, if you're really needing help, don't just sit there needing help and doing poorly. Contact me and or Robin. And I'm happy to talk with you individually if you need extra help. I mean, I really want you to do well. My goal isn't to make your life miserable, even though I may feel that way right now. My goal is really to help you understand this.
Okay.
Okay, guys? Well, if nobody has
Yeah.
questions, then I'm going to end the call. And good luck, everybody.
Thank you.
Good night, everyone.